Hello Legacy Sabers, Marsh here. So today we're going to graph parabolas in Vertex or Intercept form. You're going to want those 2 note sheets I gave you in class, plus your notebook because you're going to take a little bit of extra notes as well. Learning objectives. You're going to be able to graph quadratic function when it's in Vertex form and also when it's in Intercept form. Who would have thunk? So we've graphed in standard form. That was ax squared plus bx plus c using the vertex of negative b over 2a. Now, sometimes your vertices are like decimals, and it's gross. No one wants to graph that. So there is a vertex form, another form for us. Now, we're going to have to remember our shifting that we've been talking about, our transformations. So the ability to move up, down, left, or right, left, and reflections. Remember, this guy was an up, this guy was a down, this was right, because remember, inside was always opposite of what you wanted it to do, left, and then reflection. Same thing's going to look similar when we're doing our parabolas today. Not much different, just a little different looking of a form. Properties of vertex form, something you're going to want to know about. First thing, H represents the horizontal shift, how far left and right the graph has shifted from x equals 0. K represents the vertical shift, so looks like this, ax minus h squared plus k. You're going to want to write this down if you haven't started already. Vertex is h comma k, so how far left, how far up and down. Let's take a look at vertex form here. So I got the equation f of x equals 1/2 x minus 3 quantity squared minus 5. So we're going to want to make some notes about our transformations. I see a vertical compression. Vertical compress of 1/2. And then I see a right 3 and down 5. Those are my transformations that I'm seeing in this particular graph. So I'm going to move right 3, which would be the equation. Normally, what I got from my equation here is, if I'm looking at 3 dots, -1, 0, 1. This would be our parent function of x squared. That would have been 1, 0, and 1, right? So if I move right 3, aka I'm going to add 3 to each of your x values. So that would be the equations of 2, 3, and 4. Y values have not changed, however. Then what would happen is we would make our vertical compression of that 1/2, aka multiplying all of our y values by a half. So x, y, 2, 3, 4, and then we got a half, 0, and a half. And then I'm going to move down 5, which would take all of these and move them down 5. So 2, and that would be negative 4.5 right there. 3, negative 5, and then 4, negative 4.5. Right there would be my graph. So my vertex, we found it, was at 3, negative 5, aka I moved right 3, down 5. It is a minimum, an absolute minimum there. Axis of symmetry, we talked about this in standard form as well. Notice this guy has it right here at x equals 3. That's where I can perfectly fold him. Concavity, remember, up like a cup, down like a frown. This guy is up like a cup. End behavior, 2 guys we gotta check. As x goes to negative infinity, what is y doing? And as x goes to infinity, what is y doing? So as I'm going to negative infinity, it looks like I'm going to positive infinity on your y's. So I'm going to the positive infinity under x. Looks like y's are also going to positive infinity. Okay, so let's take a look at the rest of our key features. So I have 1/2 x minus 3 squared minus 5. So we're going to find our y-intercept. Remember, to find your y-intercept, you're plugging in a 0 for your x. So I got 1/2 0 minus 3 squared minus 5. It looks like it's going to be negative 3 squared minus 5. Technically, I'm equal to y here. 1/2 times 9 minus 5. So that will be 9/2 minus 5. Negative 1/2. So my y-intercept is 0, negative 1/2. X-intercepts, remember guys, you have to set equal to 0 and solve. So I'm going to 0 equals 1/2 x minus 3 quantity squared minus 5. We've solved this. Solve by square root, right? So let's add 5 to both sides. I got 5 equals 1/2 x minus 3 squared. Multiply by 2 to get rid of that 1/2. So that'll be 10 equals x minus 3 squared. Looks like we got a square root. So I get x minus 3 equals plus or minus square root of 10, or x equals 3 plus or minus the square root of 10. So my two x-intercepts, making a little note over here, are x, or no, whoops, not x. It will be 3 plus or minus the square root of 10, 0. Those are both of my x-intercepts, which approximately will give me a value of about 6 and just under negative 1, kind of, pretty close. Just under 0 and 6 would be the two numbers those approximately come to. Continuous, we are definitely continuous. Boundedness, we are bounded. This guy was bounded below, looking at my graph above. Domain, how far left and how far right? I can go forever to the left, forever to the right. So negative infinity to infinity. And yes, I'm going to tell you a secret. All parabolas have that domain. Caught me. Range, we're starting at negative 5, going to infinity. Bracket on that negative 5. What about increasing and decreasing? So, looks like I am decreasing on this graph from negative infinity, because we're talking our x values, till 3. So that's decreasing. And then we're increasing from 3 to infinity. Now, vertex form, totally awesome. I love vertex form a lot more than standard form. So if I want to convert to vertex form, what you got to do is complete the square. Woohoo! You know how to complete the square. So the only problem with this one is it's a little bit different. You're going to have this y that's going to just hang out over there. But with the same process, we're going to add, kick c to the other side. Ooh, that was really crooked. We got y plus 2 equals x squared minus 2x, and then we're going to add our blank. Now we also got to add blank over here. Almost forgot that. And remember, finding blank, we had to take our b value, negative 2, divide that by 2, negative 1, and then square that, which would be 1, right? Well, then we knew that this turned into a perfect square. So I need two numbers that multiply to give you 1, but add together to give you negative 2, which I think would be x minus 1 times x minus 1, aka x minus 1 squared. And then you have y plus 3 over here because you had to add the 2 and the 1. And then since you want to be equal to y, kick the 3 over to the other side. And now you have a vertex equation. Notice, I can easily now find the vertex of 1, negative 3. That would be harder to find on a standard form because you have to use that negative b over 2a business. Now, properties of intercept form. What do we need to know about it? Well, the x value of your vertex is halfway between the two intercepts. Since it's intercept form, basically it's going to show you where your x values are, where your x-intercepts are. Those two x-intercepts are going to be p comma 0 and q comma 0. Let's take a look. So I got the equation x plus 3 times x minus 1. That's what we're going to graph. Those are your two x-intercepts. So I know that I have an equation at negative 3, 0. That's one of your intercepts. And I have another intercept at 1, 0. So on my graph, I'm going to mark those in here. Now, what's cool about that? My vertex is in the middle. Smack dab in the middle of those two intercepts. So if I move over here, looks like my x value will be at negative 1 for my vertex, where that's going to be located. Now, I don't know what the y value is, so we're going to have to take that negative 1 and plug it in. So I got negative 1 plus 3, negative 1 minus 1, so that'll be 2, negative 2, so that looks like it's negative 4. That will be where my vertex is located. So negative 1, negative 4. Whoa, that was a really bad drawing. Nevertheless, it works, right? My vertex, we found it to be at negative 1, negative 4, using our eyes and finding where the average was between those two intercepts. Again, this is a minimum. Axis of symmetry. Looks like I can fold this guy perfectly at negative 1, right? So x equals negative 1 for my axis of symmetry. This guy is concave up like a cup. And behavior, we got as x goes to negative infinity, y is going to, so as I go to the left, what's going on the left of my graph? We're going up, so infinity. And then as x goes to infinity, y is going to also infinity. Y-intercept, remember how to find a y-intercept is plug 0 in for our x value. So we're going to go 0 plus 3, 0 minus 1, we're equal to y. So y equals, that's 3, negative 1. So it looks like y is equal to negative 3. So my y-intercept would be at 0, negative 3. X-intercepts. Awesome! It's already factored. Woohoo! Don't have to do much. All we know is that x is at negative 3 and x is at 1 because it's already factored. So if I write those in our ordered pairs, got my two x-intercepts. Got my zeros. This graph is a continuous graph. No breaks. Ooh, continuous does not have any silly hand. Boundedness, we are bounded below on this graph. Domain, just like every single one of these, it's been negative infinity to infinity. Our range looks like it starts at negative 4, goes forever up. Let's look at increasing and decreasing now. I am increasing from negative 1 to infinity. There we go. And then I'm decreasing from negative infinity to negative 1. Now you're probably saying, Marsh, love intercept form. So much easier. Only 2 points. Don't have to plug stuff in except for one x value. Totally agree. So, if you want to graph an intercept form, every single one of these, well, all you need to do is factor the standard form of the equation. So I got this equation of y equals 3x squared plus 6x minus 72. We need to factor him. Now you're probably just going to be like, oh, 3 times negative 72. Careful. I think a 3 comes out of every single one of those. Gonna make our life easier. So I got 3 factored out. So that'll be x squared plus 2x minus 24. Just divide the 3 out of everybody. That 3 is going to have to sit out front. That's going to be like a stretch value if you want to consider it that way. Just need to factor the inside here. So we're looking for a value that multiplies to give us negative 24, but adds together to give us 2. 6 and negative 4, I think will do the job. So since our a is 1 now, we can just jump immediately to the factored form. And that would be our intercept form of that particular standard form. Definitely a lot easier to find our intercepts, and definitely even more easier to find your vertex. You don't have to use that formula. And with that, that's the end of the video. We'll do an example of vertex form in class and also of intercept form, so you have time to ask some questions. But until then, see you later, Sabers.